Hi, I'm Mike from Craft Supplies USA, and today I'm going to show you how to turn a cranktop mill set. It's a fun little project that doesn't require a lot of material, and they're super easy to turn. Today's blanks, I've got these really cool laminated blanks with Bacote, Paduke, and some zebra wood. So these blanks are prepped, they're ready to turn, so let's get to the lathe and I'll show you how to do it. Alright, so we got our lathe set up, we've got our blanks prepped. On these I did mark the center points because I want to make sure that because it's a laminated blank, I wanted to make sure I'm dead in the center on each end. That way these bands here run straight. If you're not directly on center on both ends, you're going to have crooked lines if you're using a laminated blank. Solid material doesn't really matter as far as if you're using a regular blank, but for these I wanted to make sure I found the exact center point. So I marked both of these. We can put them between our center points, and we'll turn these to round and put a tenon on it, so then we can put it in our chuck and drill out the holes for the grinder components to put into. So let's get these mounted up and we can start roughing them out. Alright, so we got our lathe set up, we've got our blanks prepped. On these I did mark the center points because I want to make sure that because it's a laminated blank, I wanted to make sure I'm dead in the center on each end. That way these bands here run straight. If you're not directly on center on both ends, you're going to have crooked lines if you're using a laminated blank. Solid material doesn't really matter as far as if you're using a regular blank, but for these I wanted to make sure I found the exact center point. So I marked both of these. We can put them between our center points, and we'll turn these to round and put a tenon on it, so then we can put it in our chuck and drill out the holes for the grinder components to put into. So let's get these mounted up and we can start roughing them out. Alright, I've got my tool rest set. Give that a quick spin, make sure you're not contacting the blank, make sure everything's locked down nice and snug, and then we'll be using our spindle roughing gouge to rough this to round. As far as my cutting edge, I want that to be on center working height, and then make sure you wear some proper safety equipment. And because we're turning exotic woods, I'd recommend wearing a dust mask and definitely have your dust collector going as you're turning these. So we'll start the lathe at 0 and we'll bring this up to speed. We'll start roughing this out about 1800 RPM, and once it gets to round, we can bump up the speed just a little bit more. But you can see I've got the handle just a little bit low. Right now, flute's at about the 1 o'clock position. And we'll just start peeling off some of the material. Once I get close to the headstock end, I'll rotate that flute to about 11 o'clock and start cutting from the tailstock towards the headstock. Pretty close to round there on this end. Getting pretty close. I will bring my tool rest in just a little bit. Alright, I think we're right about there. Let's stop the lathe and take a look. Okay, so you can see now that the blank's round, we've got a really cool pattern. I think this will turn out really nice and be a good looking contrasting set between these different materials that we have laminated together. But you can also see once we've cut through a lot of the exterior, you can get a good look at your joints on your glue and see if you had a really good bond between the materials. If you had a bad bond, you'd see gaps between the different species of wood in different areas on the piece. So it looks like we have a good uniform bond, nice and flat all the way across the different seams. So that's what we're looking for right there. If you did have any gaps, right now I'd probably get some thin CA glue and try and have that wick in there and fill those little voids and give you a better bond so this doesn't come apart as you're turning it. I've got a tiny little flat spot right here on the top. I'll probably just leave that for now. So this blank we started out was basically 2 3/4 by 3 1/4. It's a little bit longer than the finished mill will be, so we will be removing some material here on the ends. And for aesthetics wise, I kind of want to match this shape that we have here And this finish diameter down here is basically 2.5, so that's what we're going to be shooting for on this end, and this is just a little bit smaller. And you can play around with the different shape and the contour of your mill as well. So take your design into consideration, and that will change your starting size of blank and your finish size as well, because we could definitely neck this down and make it a little bit narrower at the top. We could make this wider at the base or narrower, so play around with some different styles. But now that we have this round, I will put a tenon on one end so we can mount it into our chuck and use our Forstner bits to drill out the interior for our mill components. So I'll raise my rest slightly. I'll be using my skew as a little peeling cut to make a tenon. And then I'll just square that up slightly with the tip of the skew. And then I like to chamfer my tenons. I don't like having really sharp edges on things, so I just throw a little bit of a chamfer on that end. Now we can take this off the lathe, and then I'll get my other blank and do the exact same process. Alright, so both of our blanks are turned around. We have a nice tenon on there, and it's worth noting that we did leave this tenon pretty large because I want to maintain this diameter for our finish size. If I turn this to fit the chuck jaws at the ideal fit on the chuck jaws, this would be a lot smaller and we'd have to part this off completely and we wouldn't be able to use this bit of material. So I've left the dovetail pretty large on this, but now these are ready to go in the chuck. And the chuck I'm using is just the VM100, and I've got the shark jaws on there. It's just kind of a handy all-around jaw to have in your toolbox. We'll give that a good spin. Alright, so I'll just put this in the chuck, and I want to make sure that I don't have a corner of the jaw clamping down right on the seam. That might try and split those two pieces apart. So make sure your corners of your jaws aren't directly in a seam there. And then make sure that's nice and tight. I will be marking this top and bottom just so I remember. So I'm just going to put a B with an arrow. And I'm making this the top because this has the tenon on it. And we'll be reducing this size of the diameter here for this curve that we have. So I'll make this the top, this will be the bottom. And then for drilling, I will be using a keyless chuck, and the drill bits I'm using is a 1 3/8 and then a 1 1/16. You can use the 1 1/2 on the very top, but I'll just be using my skew to cut that recess for this little O-ring piece and the cap. The instructions call for a 1 1/2 on the bottom, but I've found that a 1 3/8 gives me a tighter fit between the turn plate here on the bottom and then the wood itself. So you can use the 1 1/2, but I prefer the 1 3/8 just for the tighter fit with the turn plate. So let's turn this on and see if it's spinning and running true. The face of that's actually pretty flat. I'm not going to true that up at all, so we can mount our 1 3/8 bit in there and cut that recess. So that 1 3/8 diameter bit will be drilling 3/8 deep. It's basically just a little bit shy of the length of the head of the Forstner bit. So we'll bring this up into place, and we need to drop our lathe speed down to about 500 RPM. And then what I like to do is bring that up so the tip of the Forstner bit's kind of touching, and I'll advance it to where it finds its natural center point, and then I lock everything down. And then just slowly advance your bit into the material. Okay, so what we have here is we have the 1 3/8 hole, and then the Forstner bits don't really cut super clean, so what I'll do is I'll get my skew and just clean up that surface just a little bit. But for now, we can use that 1 1/16 now to drill the rest of the way through the body. So we'll switch bits now. We'll bring that up, start the lathe again, and then also I like to find the natural center again before I lock it down, and then we can start cutting. And then drill this nice and slow. We are drilling some really dense exotic materials here, and we're cutting into end grain, so we want to drill nice and slow and not generate a lot of heat. These exotic materials don't like a lot of heat, and especially where we're using dissimilar materials, 3 different species of wood, we want to make sure we drill this nice and slow, keep it cool. I'll drill that as far as I can with the bit. I won't be using an extension. I'll flip this around and then we can drill from the other end. That way the holes match up and it's a little bit straighter than trying to drill this all the way through with one bit. So. Alright, so now that we've got our 1 3/8 bit drilled and then the 1 1/16 drilled, I just want to clean up the opening here and give that more of a presentable surface so we don't have any torn grain exposed or anything down here on the bottom. So we'll rotate our rest around. And if you plan on doing a slightly undercut foot here, make sure you account for that length or the loss in length if you do undercut that a little bit. So I've drilled this just a hair past 3/8. That way I can give myself a slight taper towards the center, and that way it'll sit nice and flat on my tabletop. We'll bring up our speed, and then I'm just using the tip of the skew here just to clean up that surface on the inside. You could do the same thing with your spindle gouge. You could get in there and use that as a bevel riding cut to cut a really clean surface. Just use whatever you like. And then I will clean up the face of that step. Alright, so if you've turned one of these before, you'll notice that I didn't drill the 1 3/16 Forstner bit right here to fit the female grinder mechanism. We need to recess this little step right here. And in the instructions it calls for a Forstner bit, but I prefer to do that with my skew. I get a little bit tighter fit when I do it that way. So you can either use the 1 3/16 or you can use your tools to cut that. So I'll show you how to do it with a skew. And we're cutting this 1/8 of an inch deep. I'll move that out of the way. So we're just a little bit proud. The mechanism's sticking out just a little bit. We need to cut that just a hair deeper. There we go, that's sitting in there nice and flush. And now I'm just gonna clean up the torn grain that's kind of curled over here just on the inside. Alright, so if we look inside now, we've got the little step in there to fit our grinding mechanism. We've got a nice clean face here on the 1 3/8 hole, and then we've got that 1 1/16 hole drilled most of the way through. Now I'm going to concave the bottom of this foot and basically sand and finish this bottom face here, because once we flip it around and put it in our chuck jaws, we're not going to be able to access this anymore, so I want to make sure this is sanded and prepped. Be using this is a 1/2 inch spindle gouge. You can see it's just slightly undercut here. Just cleaning that surface off, and then I like to chamfer this opening edge. And then we can get our sandpaper out and just lightly sand this because we have a really clean surface off the tool. So I drop my lathe speed down and I'll start with 220. So our lathe speed, we're at about 1,000 RPM. And then I'll also sand the inside of that step. Then I'll touch the chamfer, just sand that over a little bit. And then if you want to roll over your sandpaper, you can get in there and sand the drilled hole as well. We'll go to our 320. And then I'll use some scratch free down here on the bottom, as well as the inside of that drilled hole. And if we stop the lathe and take a look, we should have a really clean surface. No torn grain, sanded well. You can see we have that slight chamfer, our 1 3/8, then that little step for the mill mechanism, and then we've sanded the opening as well, just to clean up any torn fibers or anything in there from the Forstner bit. You can also see that the foot is slightly concave, so it tapers towards the inside. That'll give us a really good base once this is finished to sit onto your tabletop. So we can take this out of our chuck now and do the exact same thing to the other mill blank. All right, so the point we're at now is we have both of the mills drilled with the 1 1/16, the 1 3/8, and then we've cut that little recess for the mill mechanism to fit into. You can see it's nice and flush with this flat surface here, and then it fits nice and snug. There's no play in it. That's going to help long-term durability as well as just how tight the mechanism feels when you're using it, because there's not going to be slop with the mechanism housing. So this is also undercut here and sanded. So now we can flip these around, finish drilling all the way through, and then we can cut the recess for the crank top piece to fit into as well. I'll be switching my chuck out. So we're going to be going from the shark jaws to my pin jaws. That way I can fit those into that drilled hole. All right, so we've got our VM100 here with the pin jaws. This is just a handy set of jaws because we can expand into a drilled hole, especially if you're doing a lot of pepper mills. These pin jaws are really invaluable. You can use them all the time. If you don't have the pin jaws, you can turn a little tapered section of wood, use it as a jam chuck, as a drive like we do a lot of times. But the pin jaws are really handy. One thing that's worth noting with these jaws is I don't want to crank these down because we do have a ton of different glue joints in here. And if we overexpand this, it's going to pop those apart. So I want it just snug enough to hold the piece so we can turn it and drill it, but I don't want to over tighten that and pop those glue joints. So now from this end, we'll finish drilling all the way through to where that hole meets up with the 1 1/16, and then we'll cut our recess for the crank top piece to fit into. About 500 RPM again, and then make sure everything's nice and loose until that Forstner bit engages and finds its center point, and then we can lock it down. All right, you can hear the sound change with the drill bit. That means we're through to the drilled hole on the other end. And you want to be careful making sure you don't go through all the way past here and hit your pin jaws with your Forstner bit. All right, so for the opening on this end, we need to cut a recess to fit the crank top. There's a little step here, You can see it's about 1/8 of an inch deep. So we're going to use a skew to cut that. You could use the Forstner bit if you wanted to, but I want to make sure that this O-ring piece fits in there nice and flat, and then that way it's not visible from the outside, and then this will sit in there nice and flush. So I'll be using a skew for that. You could use a Forstner bit, but I want to use a skew because it's going to give me a little bit cleaner cut. So use whatever you'd like. All right, so we're about 1800 RPM. I'll be using the skew to do this, and it's going to be about 1/8 of an inch deep. All right, so we just cut the recess for the crank piece. So that fits in there nice and snug, and there's barely any slop, but that's going to give us a good consistent rotation, and that'll match with the grinder components as well on the bottom. So having these two pieces fit nice and snug in the material and not having slop is going to lead to a better functioning mechanism as well. So now that that's cut, I will just clean up the face here, make this basically flat. You could do a little concave to it, but I don't want to affect the depth of that recess we've cut. So one thing that I like to do when I'm doing these cranktop mills is I like to take them off the chuck and do a rough fit of the components to make sure that my length and my drill holes are all right, and make sure I have enough room for adjustment in the mill mechanism. Depending on how deep you drilled your holes, if you're plus or minus a little bit, you want to make sure to test fit all the components so you have enough adjustment in the grinding mechanism. Sometimes we go to put that together and there's just a teeny bit of thread exposed. If that's the case, then you need to shorten the length of the overall mill on this top end and then cut your recess again. So it's good practice just to pull this off the lathe, put all your components in there, just make sure that you have enough room of adjustment in the mill mechanism. So now that we have plenty of adjustment here, I'll take these out, we can throw back on the chuck, and it should be running true. So. All right, so this one ended up being about 3 1/4 inches long. I did drill that 1 3/8 hole just a little bit deeper than I needed to, so that's why I've left this one a little bit longer than what the instructions call for, and that's why it's always good practice just to check and do a rough fit of the components and make sure your lengths are correct. So basically 3 1/4. This one I believe is right at 3 inches, but depending on your drill depths and everything, you can play with the overall length of the mill a little bit. So now that we have this rough fit, we know the components fit and everything, and our drill holes and everything are good to go, I will chamfer the opening edge of this and just clean up that drill hole slightly, and then we can bring up our tailstock to do the rough turning of the body. So I'll get my skew just to chamfer that inside edge. One thing that's kind of cool with these mills is depending on the shape that you have, you can get a small hollowing tool and open that up to hold more pepper or salt. So play around with different designs and styles. So for turning the body and getting the final shape that we want, we can get our 60-degree revolving center, and that'll line up really well with the chamfer we just put on the inside of that drilled hole. And then we can tighten everything up and get our tool rest set. Now from here, I want to match basically the aesthetic of this and that we have, so it'll be just a nice little tapered body profile with a chamfer on each end. I'll get my pencil and mark the outside diameter of what I want the top of the mill to be. This dimension is not too critical because we haven't turned the other one yet. Once we turn the other body, we'll want to be getting some calipers to measure and match that these two are the same. checking my diameter here. I will be removing this about 1/8 inch more on this end. Just using the spindle roughing gouge to get the majority of that bulk out of the way. We're right at basically our finished diameter on the end here, and then we got a little bit to go on this end. And then I'll use my spindle gouge with a nice little bevel writing cut. That'll give me a really clean surface. And we'll come from this side. All right, now that we're to our diameters that we're trying to shoot for on each end, we can sand the body and then we'll cut our chamfers in, because the chamfers will cut really clean and I want those to be nice and crisp. I don't want to sand those and round them over. So we can sand the body now. So we'll drop our lathe speed down. And obviously make sure you're wearing a dust mask or something, or you have dust collection going with these exotics. Let's stop and inspect the surface before we move on. Okay, and it's worth noting too, as you're turning this, double check your glue joints. There might be some voids deeper in the material as you reduce the diameter. So double check those as you're turning it. But it looks pretty good. There is a little bit of tear out here on the zebra wood I want to clean up with a little bit coarser grit. So I'll actually drop back down to my 220 right here. And then I can go back to my 320. Just to get rid of any radial sanding marks, I just want to sand this lengthwise. Okay, now we'll go on to my 400. And same thing, get rid of those radial scratches. And now we can cut our chamfers on each end. So we'll bring our tool rest back up and we'll bring our lathe speed back up to that 1800 RPM. I'll use my skew to cut a chamfer. And then before I hit this with scratch free, this Paduk is pretty porous, so I'll hit this with a little bit of an air compressor just trying to get rid of some of that dust. Okay, now that the surface is ready, I will hit this with scratch free. I will remove the tailstock though, so I can access the opening here and the end of this blank. We'll get our tool rest out of the way as well, and we'll keep our speed at that roughly 2000. This is going to help refine that surface, and with those exotic timbers you get a really good luster off the material when you polish it to a higher grit. And once we're done turning both the mills, we will be putting the finish on off the lathe. Probably just be doing some tried and true oil on these. Then we'll get a clean rag and just remove any excess wax. Let's take this off the lathe and inspect our work. So you can see we've got a really good contrast between the Bacote, the Padauk, and the zebra wood. I think that's a really pretty combo. Nice straight grain orientation there with the laminations that we did. And with that material being prepped, it takes a lot of time out of the process. So we've got clean drilled holes, cut recesses for all of our components and everything to fit into, and a really clean concave base here on the bottom. So this is ready to assemble other than our final finish. I'm going to get the other body turned to match this one, and then we can go through the finishing and assembly process of the cranktop mill. Alright, so we have both of the mill bodies turned. They match up pretty close. The dimensions and diameters are basically right on the money, but we've got a really good glue joints between all the different materials. Really good shape. I really like this. So now we're ready for the final finish and then the assembly. So let's go over to our table. We'll throw a coat of tried and true on this, get our final finish on there, and then we can put these together. Alright, so we're back at the table. I've got my mill set out on a rag for the finish. I've got my tried and true ready to go, and then I have my mill components laid out. That way it helps me keep track of all the parts. We already did the rough testing on the assembly when we were on the lathe to make sure we had enough length for the adjustment. All the drilled holes are nice and clean. We've sanded and prepped the surface ready for finish. As far as my finish choice, I'm just using the tried and true. I'll be doing a single coat on these. The wood has so much oil content in it already. It's really durable material, so I don't need to go too crazy on the finish. If you wanted to, you could use friction polish, Mahoney's oil, natural mineral oil, whatever you want to use. Really doesn't matter with this stuff. So put on just a single coat of this, and then we'll come back in a few hours once it's basically dry to the touch, and then we'll assemble the mills. As I'm putting this on, you can see that tried and true really brings out the natural color in the Padauk and the Bacote, darkens up those nice lines in the zebra wood, really makes the figure and color pop in this material. I will coat the opening of the drilled holes on each end, because anytime I make a mill that I'm going to give away or sell or anything like that, I want to make sure that the inside opening areas are finished. That way when they take them apart to refill them, there's not a bunch of natural timber in there or anything that's discolored or anything. So I want to protect those surfaces and make them look as good as they can for as long as they can as well. Just give that one last buff on the exterior. Set one off to the side, and you can see just the difference in contrast in color between the finished one and the unfinished. That tried and true really makes these natural colors in the wood really come to life. Alright, so we'll just close that up, and I'll let these sit for a few hours. Once they're dry to the touch, we'll come back and we'll show you how to assemble the mechanisms, and then you can have a nice set of finished mills with some really exotic timber. Alright, so we've let the finish dry, so these are ready to assemble. Before we do that, let's go over the parts and the correct terminology. That way when we put these together, you can reference the parts on the instructions and you can get these put together correctly. We have the mill shaft, the spring bar, the spring, the crankshaft, the plastic washer, the male grinder, the adjustment knob, the female grinder, the cover plate, and the cover plate screws. Alright, the first thing I'm going to do is I'll drop the cover plate into the drilled hole. This way we can pre-drill for our screws for the cover plate. And I'm going to have the screws going into the Bacote because it's going to be a little more durable than the zebra wood. It's a little harder and denser. So I'll center up the cover plate as best I can, and then I'll be using a 5/64 drill bit. And I'm angling the drill bit tip slightly towards the outside of the mill because there's more material there. I don't want to have the screws coming into the body of the mill itself. Alright, so first thing I want to do is grab the mill shaft. I'll put the male grinder on there with the square on the bottom. Then we'll grab our female grinder, making sure the text is down. Then we'll grab our spring with the small end facing down. And then we can grab our spring bar and slide that right over the top. I will line up the cutouts in the female grinder and the spring bar, make sure those tabs are aligned. And then we can drop this into the mill. Just use my screwdriver to help me line up the tabs with the two parts and the drilled hole. So when you're dropping the parts in, you may need to get a small screwdriver to help you align the mechanisms with the spring bar. And then we can press that down into place. Once you have all those components pressed down, let's grab our cover plate. And if you need to, you can pull on the bottom of the rod to help maintain the tension on that. And then I'll just use my thumb to keep all that assembly pressed into place. With all those components lined up with the spring bar and the female mechanism and the cover plate lined up with the holes, let's get our crank top. We'll press on the plastic washer onto that shoulder, and then we can put that into the mill head, or the mill top of the mill. Throw on the adjustment knob and just snug that down for a second to keep all these components in place, and then we can put our screws in for the cover plate. Now we can screw in the cover plate. Alright, so now that we've assembled our mill, we also went ahead and assembled the salt mill as well. The only thing left to do now is just take off the crank tops, and we can fill these with some salt and pepper. It's like we talked about before, if you do open these up with a little hollowing tool, you can definitely hold some more pepper or salt in there. But once you fill them up, drop your crank top on there, and then I like to push the grinding mechanism in just a little bit, just gives me a little more thread to engage with the crank top. And then the coarseness is just done by adjusting this knob looser or tighter. It'll give you a finer or coarser grind depending on what you like. So this will be pretty loose. Get a nice coarse pepper, or we can tighten that down quite a ways and get a really fine grind. Got the salt on there, got a nice grind. The nice thing about these crank top mills too is they're really good for barbecues because you can put out a ton of salt at a time, ton of pepper, really easy to use. So now we have a nice matching set, salt and pepper, really cool unique look with the laminated exotics. Alright, so we've got our mills complete. It's a fun little project, doesn't take too much time. If you have any questions, leave them in the comments below and subscribe to our channel for more wood turning videos.